Cool. All right, so tonight's lesson's a little weird. That bear in mind what you're going to be doing. You're going to be taking a matrix, let's call it A, and you're going to be breaking it apart into an L and a U matrix. You're factoring in essence. Okay? Now, keep in mind that there's some things we teach you that, doesn't have, like what would you use this? Well, back in the day, it was a very easy way to solve some systems. Number one. Number two, kind of some stuff that a calculator, computer can use in its algebra system. But it's, again, not a very hard concept, and it's something that's on the menu, so, I have to do it, so here I go. Now, remember, if you have AX equals B, okay, and then we can solve this, right, where this is a matrix, and this is equal to a vector, right, and we said we take A inverse, and we're done, right? Cool. Well, what we're going to do here is we're going to do it a little bit different. We're going to rewrite A as a matrix L times a matrix U times X equals B. Okay. Now, we're going to take that L, and we're going to take and then multiply U times a vector. And what happens when you take U times a vector? Well, U times a vector, U, of course, is a square matrix, because obviously this is a square matrix, times this guy. So this is let's say U is n by n, and then X is n by 1. So this times this is n by 1. And then, of course, is equal to n by 1, because this is an n by n. Make sense? Now, what we're going to do here is we're going to end up taking this guy, and we're going to be able to solve a pretty good, cool, easy way to solve this problem pretty straightforwardly, as a matter of fact. So in essence, what we're going to be left with is this right here, again, is a vector. It's going to be the vector that we're solving for, in essence. This piece right here, then, this guy is going to be a really cool deal. So we're going to basically take what's left in this matrix and equate it to this guy over here, and then solve the equation. Okay. When we're done in a minute, I'll show you how that works. Back in the day, that was the point of doing this. Keep in mind that once you're past a 2x2, it's a giant pain in the tushy to find an inverse matrix. Once you found the inverse matrix, then you have to find the determinant. Then you have to find, doing all the inverse. I mean, you have to do the determinant if you follow the inverse procedure I showed you today. But you do all that, and then multiply it out, cross your fingers, and then hope that you didn't make a screw up somewhere. The idea was this is another way to solve, and quite honestly, it's not a very hard way once you learn the gist of it. Okay, so it's pretty straightforward, and so what we're going to do is we're going to demonstrate how this works. So, that's the game. So the whole point is we want to find L and U, okay? And so first of all, let's start off with A is square matrix, okay? And so we're going to be able to write A equals LU, as I mentioned previously, okay? Where L is the unit lower triangular matrix. And U is the unit upper triangular matrix. Okay? So I will demonstrate what that looks like. So a particular U would look something like, whenever you have a U, let's say it was a 3x3 U. This is 3x3. These guys right here will be zeros. These will be non-zero entities, the other 6 places. So for instance, could be this, could be that, this, and this. These 3 guys down here, this is what makes it a unit upper matrix. Okay? And then L is exactly what you think. An L matrix will always look just the opposite of that, where these upper 3 in the corner will be zeros, and everywhere else will be, well, it could be zeros. Some of them can be zeros. You don't know. They are just any random number. It doesn't make any difference. Don't have to be ones. Can be negative. Just there we go. Okay. Excuse me. So that's That's the long and the short of it. Now, once we have these, you're going to see what happens here in a second, and I'll demonstrate it for you. It's almost fun, actually. The question is, how do you get here? And so that's where we're going to go. Okay, so first and foremost, one should always, in my mind, start by doing I always start anyways, finding the, just a minute. Just a minute, I gotta take it. Sorry, I'm back. So what you're going to want to do is I'm just going to make up one here. And I'm going to make up this problem. And so I'm going to make up one that I know has a solution. Okay, so I know this sucker has a solution. So my A matrix is this guy. Yeah, that's my A matrix. Okay, again, multiplying it by x, y, and z, that's my quote-unquote x vector. And it's going to be equal to this guy right here. Now again, to solve this guy, you could do augmented matrices. Of course you could. You could do reduce row echelon with that. Boom, piece of cake. You could do the matrix equation, find the inverse of this guy. You certainly could do that. Again, kind of a giant pain. So in the past, what they've done is they've rewritten this as L times U times X is equal to, this B matrix, this B vector rather. And so that's what we're going to attempt to do. So U is the one you want to do first. So U is simply putting this guy here in echelon form. Notice I did not say reduced row echelon form. Not reduced, just echelon form, meaning you need a 0 here, here, and here. Okay? So let's go about doing that. So 3, 2, 1. And then so to get a 3 here, you're going to go, to get a 3 there, you can do it a couple of ways. I'm going to take 2R1 minus 3R2. That's going to give me 0. 4 plus 3 is 7. 2 minus 30 is negative 28. And then to get a 0 here, I'm just going to take R1 plus 3R3. 0. It's going to give me 2 plus 9 is 11. And that's going to give me 1 minus 18 is negative 17. Okay. Now, simply need to get a 0 here. So I'm going to take 11 R2s minus 7 R3s. So we're not done yet. We're headed that direction. It's not U yet. So to get U, we got to finish up. And then you're going to get, again, we're not changing this guy. Then you get 11 times a 0, duh. And then you're going to get 77 minus 77 is 0. Good night, nurse. Who's the idiot that fixed these problems? My word, what a moron. 11 times negative 28 plus 7 times 17, negative 189. This right here, friends, is my U matrix. That's it. That's all there is to that guy. You're like, well, that's cool. Neato. And so, yeah, that is kind of neato, I guess. Now, what I'd like to show, though, for just a moment is there a way we could have done this differently? And when I mean differently, I want you to see this because the way I'm going to show you next is the way that you're going to want to do it, because this next method, -2, -1, 10. And what I mean, we're not done yet. We got to find the L vector. But the way we find the L vector has to do with how we got rid of things. -1, 3, -6. Okay, so what I want to see is this, is darn it. I didn't leave myself enough room to write. That's all I'm upset about there. One moment, please. Cool. Let's get rid of this fella. Oh, that's cute. I brought the thing with me. Nice. Now, what I could have done is I could have taken R1 minus 2/3 of an R2. I'm sorry, 3/2 of an R2. Do you buy that? Now, that's going to be important momentarily, okay? And we could have done R1 plus 3 R3s. Do you buy that? Okay. And so when we did that, of course, we'll end up with zeros where we want them, but our answers are going to be slightly different this time. So 3 minus 3 is 0. And you're going to have 2 plus 1.5 is 3.5, which is, 7/2, I think. And then you're going to have 1 minus 15, which would be negative 14. And then you're going to end up with 0. You end up with 2 plus 9 is 11. And this one isn't changing at all. Of course, it's still 17, negative 17. So it should be the same, except that middle row would be times by 2, or divided by 2 from what I had before, correct? Yeah, exactly. So now the reason we're doing that, okay, that is a big deal. Now I want to go one step further, and now this is going to be a little gross, so I apologize right up front. I'm going to take R2, okay, and I'm going to subtract, and what I'm going to do is I'm only going to multiply R3. Okay, I'm only going to multiply R3 in this case. So the way I'm doing this, I'm going to take the row I'm taking, and I'm subtracting. I'm only going to multiply the second one. So it's kind of hard to do, but just be aware of it. So 11 times A, if you will, is equal to 7/2. It means A is equal to 7/20. Do you buy that? So minus 7/20 are 3. That should do the job. So if I did this correctly, I'm going to get 3, 2, 1, 0, 7/2, negative 14, 0, 0. And then I'm going to have, good grief, gravy. Let's try this again here. Negative 14 plus, oh, you hippie. Negative 14 plus 17 times 7 divided by 22 is 189 over 22. Negative 189 over 22. And I think we just had negative 189 before, correct? Cool. So you can see where what I've done here is the same, except that I used fractions. You're like, why on earth did you use those fractions? To get your u, Jay. Oh, I'm glad you asked, friend. I am so glad you asked. Because it turns out that L is simply, check this out, you're going to start with the identity. You with me? You're going to put zeros up here. All right. Now check it out. What am I going to put down here? I'm going to put negative 3/2. I'm going to put positive 3. And I'm going to put negative 7/20. In other words, the numbers that you used to create your U matrix go in your L matrix. Are you with me? Now you're like, I don't buy it, Jay. I don't believe you. Okay. So what should L times U give us? Well, I feel like L should times U should give us A, correct? Let's see if that's true. Oops, shoot, times if I didn't screw anything up, ta-da-da, and I did, of course, because there's a way to screw it up. Jay will figure it out. You big dope. There we go. I bet it works now. Maybe if you don't put 2 times in, it'll work, Jay. Not quite. Okay, so that means I typed something in goofy, probably. Here, let's see what I did wrong. Good Lord. All right. 1, 0, 0, negative 1, 5, 0, 3, negative 7/20, and 1. 3, 2, 1, 0, 3.5, negative 14, you loser. Okay, it's closer. All right, and let's see what else I messed up. 0, 0, negative 189 over 22. All right, I'm messing something up. Just a second while I find my mistake. Yeah, I forgot one thing. So up here, it always needs to be in terms of subtraction. So this needs to be written as negative and negative. So in theory, that should fix our issue here. So let's go see. I think that if that's a negative, I think we're golden. Oh, no. So close. All right, I'm still dropping something. One moment, please. All right, I found my mistake. Pardon me. It's the same basic premise. I just kind of forgot the one thing. Now, you'll have to forgive me. This is something I don't do but maybe twice a year, and I always have to forget about it. You'll remember on the last page when I was doing this, I was taking the... Where did they go? Well, they disappeared. You'll recall I took R1 minus 3 halves R2. Are you with me? It's got to be backwards from that. So it's always got to be the bottom one minus the one above it. Does that make sense? So in other words, R2, this guy here, minus 2/3 of the one above it to get to 0 here. Okay? So that's the only thing that's a little weird. It has to be the second one down, this one minus this one. It has to be this one minus this one, and it has to be this one minus this one to get to zeros. So when you do that, you end up with this matrix right here. So when I reduced it, I got this is my U, and then I take those values and I plug them in here. These is my L matrix. And when I tested them on the calculator, boom, I got back to my original A. That is amazing. Now you're like, okay, great, Jay, what does that mean? Okay, well, here's what it means, friends. I'm getting there, I promise, I swear. I promise. And then back to the original problem somewhere. Oopsie daisy. Somewhere on the original problem, we had equals 11, 5, and 9, right? Cool. So you're like, well, yeah, I guess cool, Jay, but whatever. Well, check this out. Remember, this times this, that's exciting, I guess. It is what it is. But what this really means is this. You can rewrite this problem as this. You can write it as, you can take the coefficients from over here, and you can write it in this fashion right here, like so. You can take the coefficients from this L matrix here, right, as x equals 11. 2/3 x plus y equals 5. And negative 1/3 x minus 11/7 y plus z equals 9. Okay? Now, lest you don't believe me, let's finish this out and see if this is true. Oh, that's funny. Okay, well, I think what that means is I can't do arithmetic somewhere else in the problem. So I'm going to pause you real quick, double check my original. No, I didn't screw it up. I just forgot this one simple little in between step. So you're going to write x1 plus y, x2. Because what you're doing is you're solving for an in-between variable. And I always forget that. And I always freak myself out when I do this. So what you're doing is you're solving for an in-between variable. Okay, I'll show you what I mean by that in just a second. So when you do this, you're going to get x1 equals 11. You plug that into here, you're going to get 22/3 plus x2 is equal to 5. 5 minus, where did it go? Oh, 22/3. Negative 7/3. So x1 is 11. x2 is equal to negative 7/3. And x3 is equal to, now listen, you know what these guys are, so let's plug it in. You get negative 1/3 times 11 minus 11/7. 11/7 times, what did we get here a minute ago? Negative 7/3. Plus, let's put in an x, equals 9. comma x, and then go back to the start of this. We'll just do solve. So F2 solve. X equals 9. So x3 is equal to 9. Cool. Now what am I going to do with that, Jay? I'm glad you asked. Because what we're going to end up doing then is a second step. And that second step is well, we're going to take, instead of equal to, so what we have here then is this, is that in essence we've solved for what the in-between values are. So what we're going to do is we're going to take our second matrix, which is our upper matrix, and we're going to write them as this. And it's going to go down something like this. So what we're saying is this, I guess. I sometimes I kind of get myself confused on this because it's a goofy thing. It's cool, but it's kind of a goofy thing. So what we ended up doing is we ended up solving on the last one. We ended up solving, in other words, L. We redid this. We redid that as, we did it as L. That was our regular L times some we called it x, if you will, and we solved it equal to this guy. Okay, and we solved for this. So what we said is we said that this times this, right, was equal to our x values here. Your book uses a y, but it makes no difference to us in that case. Okay, so what we're saying then is that ux is equal to y, and x or ux is equal to the way we did it was that. So okay, cool. So then what they did, or what you do then, is that you solve it backwards the other direction, and you can solve for what it's supposed to be equal to. So let me just go ahead and show you that in a second here. Okay, so what I did was I went back and redid it the way the book does it. So just so you're clear on that. So instead of x's, I solved for the y's. So in other words, we said u times x is equal to our y's. So what we did is we solved this equation right here. Are you with me? We solved this equation. Okay, we solved for the y's. So now we know the y's. Now we can plug this into ux is equal to y, and then we can just backfill from this guy. So again, what we're going to have then is our upper matrix. And so our upper matrix was this guy, the 3, 2, 1, 1. So it's going to be 3x1 plus 2x2 plus x3 is equal to y, which is 11, right? And then set negative 7/3 x2 plus 28/3 equals negative 7/3. Okay, and then so then you're going to have 9. This is not x3, sorry, and it's going to be 9x3 is equal to 9. That's awesome. So when we solve this equation, you're like, okay, well, clearly x3 is equal to 1. That's cool. Now you plug that in. First of all, let's times this bottom of this equation by 3 just for fun, right? So it's going to be negative 7/3 x2, or negative 7x2. And then plug a 1 in for x3. It's going to be plus 28 is equal to 7. So then negative 7x2, you subtract this over here, you're going to get negative 21. So x2 is equal to 3. Did I drop a sign somewhere? He said, hopefully. Yes, he must have dropped a sign. Was that 28 positive or negative? Did I write down wrong? Nope, I don't think I did. Alright, something's a little screwy there. Something is a little screwy. Oh, this was negative 7/3. There we go. So that would make that much better. That would make that negative 35, which would make this 5, which is what it's supposed to be. And then you plug those back into the top equation. So you get 3x1 plus 10 plus 1 equals 11. So 3x1 is equal to a goose egg. So x1 is equal to 0. So our final answer, the answer that we sought all along, was 0, 5, 1, which is the correct answer. I'm going to do another one, start to finish. I'm going to do it right this time. I'm not going to screw it up. Probably do 2 of them just for fun. And we'll see if we can get it right. I'm going to pause you while I get it typed in. Okay, this is as good a problem as any, I guess. Remember, the problem that we're looking to solve is this guy, 2, 4, 1, 1, 5, -2, -3, 1, -1, times x, y, z equals 24, 31, -17. This is what we seek to solve. First, again, we're going to go with our u. To get our u, we are going to get rid of this guy, and this guy. Remembering, though, that we're going to take R2 minus a half of an R1. Okay? So let's see if we can do it right this time. See if Jay can not screw it up this time. So 2, 4, 1. So then 1 minus 1 is 0, obviously. It's going to be 5 minus a half of 4. 5 minus 2 is 3. -2 minus a half is -2.5, which is -5/2, I believe. Cool. And then we're going to take R3 plus, which remember is really R3 minus a minus. And we're going to plus 3/2 R1. All right? So 0. So 1 plus 6 is 7. So then you're going to have -1 plus a half. So it's going to be what, half? Cool. And then I'm going to take R3 minus 7/3 R2. So whatever I get this time is going to be my U matrix. So 2, 4, 1, 0, 3, -5, halves, 0. 0, and then here we're gonna, I can't do it on my calculator, so 1/2 minus, oh, it's actually gonna be plus this time, plus 5/2 times 7/3, 19/3. Okay, this is my U. So then my L looks like this. Okay, so my L matrix, we're going to start off with a 3 by 3 in this case because that's what we're using. And then down here we're going to get we're going to get a half. We're going to get -3/2, and we're going to get 7/3. Now I'm going to check myself because I'm just not really cooking with all cylinders today. So let's go here and see what we get. Remember, it's L times U. Oops, stupid. There you go. Yes! Oh, we're cooking with gas now, folks. I think that's the right answer, isn't it? Look at that. Again, isn't that perfect? It's freaking perfect. It's like we know what we're doing now. OMG, Osh. So let's write this baby out. The crowd goes wild. See, I can't actually do this. It's just one of these things that about twice a year I get to teach this class. Which, don't get me wrong, is about enough. And so you don't get real practiced at it, and you like forget things, and you know, whatever. Once you're in it, you're like, oh, it's just a piece of cake, dude. I'm just gonna write our big X. I'm actually gonna rewrite this as X. Our vector here, you with me, is equal to, and then our solution over here. And our solution is 24, 31, -17. 24, 31, negative 17. Okay, now remember, what we're saying is we're going to call this y. So what we're going to have then, y is a vector. Are you with me? Because we know this is a 3 by 3 times a 3 by 1 gives me another 3 by 1. You with me? So it's an in-between vector. We're going to call it y. Cool. So what that's saying to us is this. When you take this and multiply it out, you're going to get 1 y1 is equal to 24. You're going to get a half of a y1 plus a y2 is equal to 31. And then you're going to get negative 1.5 y1 plus 7/3 y2 plus y3 equal negative 17. So clearly that's 24. Plug that in here, you're going to get 12 plus something equal 31. Well, I think something is 19. And so then I need a calculator because I'm kind of lazy. So negative 1.5 times 12, or 24 rather, sorry. I still screwed up. Nice work, Jay. Plus 7/3 times 19 plus x equals negative 17. It's too late in the day to do any algebra. Oops, sorry. So, shoot, dummy. Darn it. Sorry. Comma x. There we go. Oh, wait. Equals, what's supposed to equal 17, right? No, 17. So we're just going to go solve. And so if I did that right, negative 1.5 times 24 plus 7/3 times 19 plus something is negative. So negative 25 and a third. So, and I can do, well, 25 times 3 plus 1 is 76/3, right? So y3 is 76/3. So what we're saying then is that this thing right here is equal to this vector, 24, 19, and 76/3. Okay? That's that in-between amount. You're like, okay, well, what does that do for me now? Well, I'm glad you asked, okay? So again, once you're here, so what you solved for is you solved for what this thing here is equal to. That's nice. So what am I going to do then? Well, I'm going to take then 2, 4, 1, 0, 3, negative 5 halves, 0, 0, 19/3. And I'm going to multiply it by x1, x2, and x3. And they better equal these in-between steps again, because we said that this ux is equal to this y vector. And so it's pretty clear then that you're going to have 3 more equations. Well, the first one is 19/3 x3 equals 76/3. That means x3 is 4. So then you've got another equation. You get 3x2 minus 5 halves x3 equals 19. Well, if you plug this into here, 2.5 times 4 is 10. So 3x2 minus 10 equals 19. 3x2 is equal to 9. x2 is equal to 3. And if you plug those in, you get 2x1 plus 12 plus 4 equals 24. And when you do that, you get 16, that's 8. You get 2x1 is 8, x1 then is 4. So our final solution is 4, 3, 4. Is that what I said? I think that's what I said, actually. Oops. It's 8, 3, 4. So, did I drop a sign somewhere? I think I dropped a sign somewhere. One moment while I collect my signs. Oh, it's right there. It's right there, stupid. It's right here, for God's sakes. Look at this. So if you plus 10 to the other side, you get 29. Hold up. Something's screwy. It is 10. Let me pause you for a moment. Found it. This should have been negative 76 thirds, which makes this negative 4, which is the right answer that I was looking for, which makes this a positive 10, which gives me the 9, that x equals 3 that I wanted. Now let's see if I can do this right. So this should have been minus 4 right here. So that would have been 12 minus 4 is 8. That would have left us with 16. That would have left us with x is equal to 8. So 8, 3, negative 4. That was the answer that I started with. I even wrote it up here. Cool. So you can see where I'm going wrong on these. I drop a lot of signs. That's just it's always been my problem. I remember back in high school, I had this teacher who would always yell at me about it. And, you know, it is what it is, I guess. He would get so angry. And I'd say, geez, I called him coach because he was our math coach, I said. And I said, geez, coach, I said, what's the big deal? I said, it's just a negative sign. He's like, yeah, tell that to the woman who you sent her husband to the sun instead of to the moon. I went, oh. Well, I guess if you're going to make a big deal about it, you know, I mean, come on, dude, whatever. All right, let's see if I can pull this. Oh, I need to write this on a sheet of paper so I can see what I'm doing. 1. All right, so here we are. So, and then negative 24. And then x minus y plus z is 3. Is that right? No. No, it's not. It's 17. You dope. Yeah, 17. And 2x minus y minus z is 9. It's a goose egg. That's nice. All right, now we're off to the races, friends. See how fast we can do this one. 2, 5, 1, 1, negative 1, 1, 2, negative 1, 1. Negative 1. Sorry. Jeez. It's embarrassing. Again, times. Cool. All right, so let's start off with finding our U matrix, okay? So we're going to take R2 minus a half of an R1. So 1 minus a half, minus 1 is 0, and then it's going to be negative 1 minus 5 halves. I can't do that in my head anymore. Too tired. Negative 7 halves. It's going to be 1 minus a half is 1 half. And it's going to be R3 minus R1. 2 minus 2 is 0, negative 6, and negative 2. Cool. So again, I'm going to take R3 minus something times R2. Okay. So in other words, something, negative 7 halves times something has to equal negative 6, right? So if you divide, you're going to get 6 over 1 times 2 over 7, negative. So it's going to be 12 sevenths. Is that right? So we need to multiply by negative. Yeah, and so we're going to end up adding, of course. But here we go. So it's going to be 12 sevenths. Is that right? Yep. Because if I do that, I will get what I'm looking for. And so I will get 2, 5, 1, 0, negative 7 halves, 1 half, 0, 0. That better be true anyways. And then I'm going to get a half. No, I'm not. What am I doing here? I'm going to get, here I'm going to take, again, I'm taking R3 minus that. So it's going to be negative 2 plus 0.5 times negative 12 sevenths. All right. No, plus 12 sevenths. 12 sevenths. Okay, remember, you're multiplying by, no, it's negative 12 sevenths. You screwed up, Jay. At some point, guy just needs to just go to bed and call it a day because you're just like, you know, what am I doing here? I'm going to do it this way. Negative 2 and then plus 1/2 times negative 12 sevenths. So negative 75 sevenths. That's what I was looking for. Okay? Don't forget your negative. There you go. So then this is your, which one? This is your U. And then your L, again, start off 1, 1, 1, 0, 0, 0. And then the lower ones will be 1/2 and 1. And then negative 12 sevenths. And just to corroborate that that is the correct answer, let's go ahead and punch it in. Remember, it's L times U. Sometimes I get a hankering to write on the chalkboard. It goes away fairly quickly, but you know, some days you're just like, gosh, this would be so fun to just write this all across the chalkboard. That was like one of the favorite things when I first started teaching, because I'm old enough that chalkboards were a thing. Plus, you could chuck it at the kids when they were misbehaving. That was a lot of fun. I was kind of on the tail end of that. I was kind of going out, kind of frowned upon toward the later part of my career. Moron. Oh. What did you screw up this time, Jay? You see, I'm so close, except for, you know, I'm off there, right? So let's go figure out what we did wrong. Of course, you guys didn't mess it up. It's just Jay's fault. It's fine. It's always my fault. 1, 0, 0. 1/2. 1, 0, 1. Negative 12 sevenths, 1. 2, 5, 1. 0, negative 7 halves, 1/2. 0, 0, 0, negative 75 sevenths. Okay, so I just can't do arithmetic. So this middle row is correct. The bottom row there, though, should have been 2, and then whatever that is, 8. That's we're in sevenths, so it'd be 6 sevenths, I guess. 2 and 6 sevenths. Should be 14 minus 20 sevenths, I guess. I'm going to double check that that's true. Yes, okay, so that's right. So that's what's killing me here. So I'm going to try this again. I hit record, right? Yes, good. Okay, so you go away. No one's asking you. So let's try this again, see if I can't do it right this time. Again, you can see where, you know, we are very thankful to live in a world where we have calculators at the ready. But again, you're learning the background behind some of this stuff that the calculator does. Behind the scenes, that's the point of this class. A lot of other cool things we can do with linear algebra, how it works, but this is one of the things that's kind of a basis for what happens behind the scenes. Oh, idiot. Are you freaking kidding me? If I type something in wrong still. So the 12 sevenths should have been positive right here. I had it positive, and then I made it negative in here for some unknown reason. There it is, okay? So it does work. I checked it. Yay. Good Lord. So remember, actually, let's call this x is equal to negative 24, 17, and 0. Okay, remember, we're calling this bit here, we're calling it y. So that means we got y1 is equal to negative 24. We're going to have a half of a y1 plus a y2 is equal to 17. And you're going to get a y1 plus a 12/7 y2 plus a y3 is equal to a goose egg. Okay, let's get a calculator out. I don't trust myself at all. This is ridiculous. So I get negative 24 times a half plus y equals 17. Let's solve for y. So y is 29. y2 is 29. So let's plug that mess in. Oh, shoot, what just happened? So you're going to get negative 24 plus 12/7 times 29 plus y equals 0. Oops. Comma y and oops. Comma y, and then don't forget to put the solve at the front, because I did. So y3 is negative 1/87. So what we're saying is this whole bit right here is equivalent to negative 24, 29, and negative 180/7. So that's great. That's what this here is equal to. So let's solve for this vector here then. So what that's going to give us is that, starting from the bottom and working up, negative 27 x3 is equal to negative 187. So that means that x3 is equal to 9. Cool. Then let's work that backwards. So negative 7/2 x2 plus a half of an x3 is equal to 17. So negative 7/2 x plus 9 divided by 2 equals 17 comma x. Helpful if you just put the solve there to start with, dummy. So x equals 19, you goober. Remember, it doesn't equal those, it equals these guys. So pay attention to that. I'm like, it can't be wrong, I know I'm right. Boom, negative 7. x2 is equal to negative 7. Well, hot dang. So that means 2x1 plus, minus 35 plus 9 equals negative 24. This negative 24. So let's see what we get here. I can't do math. Clearly. Solve. So 2x minus 35 plus 9 equals negative 24 comma x. Bam. X is 1. Hey, lo and behold, that's what I wrote in my paper. My final answer is 1, negative 7, 9. Bam. So that is the gist of 3-4. Okay? You will make mistakes because you will drop signs. You will make mistakes because you're like me, a little careless here and there. Just try not to do it. Anyway, have fun.